So first of all, a fraction looks like this. 3/4, sometimes that when you're writing it, sometimes you can write it like this. Sometimes people write that fraction on an angle like that. What is a fraction? It's a number over a number, but what does it mean? Right? Like 3/4 is 3 out of 4. It means something different for a test, right? If you got 3 out of 4, then it would mean you got 3 right and there were 4 questions. 3/4 of a 2-liter pop might give you a picture of how much is left. But 3/4 of a 2-liter pop is different than 3/4 of a 500 ml pop. Right? Obviously, 3/4 of the bigger amount leaves you with a bigger amount. So 3/4 as a fraction, what a fraction is it's a comparison of a whole amount. And it depends what that whole amount is. So for example, if you had a chocolate bar, and I wanted to talk about 3/4 of a chocolate bar, the bottom number is how many sections that thing is divided into. So 3/4 of a chocolate bar, that would mean if I divide my chocolate bar into 4 pieces, then 3/4 would be 3 out of the 4 pieces. 3/4 of a 2-liter bottle, we'd have to imagine that 2-liter bottle split up into 4 equal sections, and we would have 3 of those sections. So a fraction is a comparison of something that is, you think of how much is 1, and then what would 3/4 of that? And one of, whoa, that doesn't look like proportion. One of the words we're going to be using a lot is the word proportion. So a fraction is a proportion. The number on the bottom, now do you know what the special math word is for that number on the bottom? Denominator. Denominator. That is how many pieces your whole object has been divided up into. So the number on the bottom, and this is not a formal math definition that we're putting up here, we're just talking to try and get an idea of the concept. So that number on the bottom we're going to say the number of pieces a whole object is divided up into. So for our whole chocolate bar that we had drawn before, when we wanted to talk about quarters, the 4 was on the bottom. That would be dividing up our whole object into 4 pieces. Now, the number on the top, numerator, awesome.
Sorry for the interruption. If we could please now have all of our grade 12 students with the last name beginning with the letter N as in Nancy through T as in Thomas, if you could please make your way to the gym for your photos. Thank you.
Is how many of those pieces you have. So you can make a fraction of anything. If I would like to take this piece of paper, I could break it up into any amount of pieces that I wanted. Right? I could fold it in half. I could fold it in half, and then I have two pieces. So when I want to talk about a fraction that's a half, right, this is 1/2 of this paper, more or less. That's because my original thing had two pieces, and I have only one of those two pieces. So that would be a fraction of 1/2. I could divide that original piece of paper into 4. Now I have 4 pieces, and these two would be 2 of those 4 pieces, so I would have 2 out of the 4 pieces. Improper fractions, so someone says, what happens if I have an improper fraction? Like 7/4. So I still have my whole piece of paper here, right? And this originally was the one piece of paper. It's hard to hold. And it's split into 4. So when I have 7/4, which is an improper fraction, I would have 7 of these pieces. And if I had 7 of these pieces, I would have had one whole piece here, and then adding 3 more means I have another 3/4. I have 7 pieces, and the bottom number is telling us how big those pieces are. So when you want to compare something, right, what's bigger, having 7/4 or 3/2? So we'd have to imagine, here's my original piece of paper. Here's splitting it into quarters, and I would have 7 of those. Here's my original piece of paper, same size. And if I cut it in half and I had 3/2, that would look like this. Can you see that the 7/4 is more than the 3/2? Now, one of the things that we can do with any fraction is we have fractions and we have decimals. And we can change any fraction to a decimal to see what it looks like. So when I have 7/4, I could type that into my calculator, 7 divided by 4, and I would get 1.75. And I could take 3/2 and type that into my calculator, and I would get 1.5. And 1.75 is a bigger number than 1.5. So we can see that in decimals as well. But the idea with an improper fraction is still the size of the pieces is based on that denominator, how big they are, and then the number on the top is how many of those pieces you have. So anytime your number on the top is bigger, that's going to mean you're going to have more than one of your original object and a bunch more pieces. That's an improper fraction. That improper fraction can be written as a decimal. It can also be written as a mixed fraction. So a mixed fraction tells you how many whole things you have, and then, so this is 1 3/4, which you can see in the picture. We had one whole piece of paper, plus the other 3 pieces didn't quite make another whole piece. So those are some things about fractions. Now what we're going to look at, and our proportional reasoning, is looking at fractions that are equivalent. What does it mean if fractions are equivalent? That means that two fractions represent the same amount even though they have different values. Now, with this piece of paper, the first thing I did was I cut it in half, right? And when I cut it in half, grab another piece here. Right? I took my whole piece of paper, I folded it in half. That gives me 2 pieces, and one of those pieces would be 1/2. Then I took that whole piece of paper and divided it into 4 pieces. And now I have 2/4. 1/2 and 2/4 are called equivalent fractions. because if I have a half a piece of paper, it's exactly the same as 2/4 of a piece of paper. Can you see that? That the 2/4 is the same as the half piece. What would be another fraction that has different numbers but would be equivalent to those? 4/8. 3/6. There's a lot more of them. We could, if we wanted to try to list them all, we could be here until we all died. But we're not going to do that. That's not today's lesson. Maybe tomorrow. Okay? There's a lot of them. How do you find other ones? Could you tell me one where there's a 5 on the top? 5/10. Okay, good. Could you tell me one where there is 50 on the bottom? 25. All right. See if I can figure out a hard one. How about 13 on the bottom? Is that impossible? Could you do a decimal? 6.5. Now that technically would be equal to a half. Now with fractions, we don't like to mix fractions and decimals, but that is right. 6.5/13 is equal to a half. Now one thing you can do with fractions is if you start with a fraction like a half, and you want to find a fraction that's equivalent, you can pick any number you like, and as long as you multiply or divide both the top number and the bottom number by that same amount, those fractions will be equivalent. So if we pick a random number, anybody have a favorite number? 8? All right. If we picked 8 and you multiplied the top by 8 and the bottom by 8, you would get 1 times 8 is 8, 2 times 8 is 16. Those would be equivalent, because 8/16 is the same as a half. So you can make an equivalent fraction by multiplying or dividing. One of the things you've probably learned in the past is that because there are so many different ways of making equivalent fractions, we have fractions in their lowest terms. So for example, if I had 50 out of 100, that's 1/2, and the 1/2 is in the lowest terms. And we have a fraction in its lowest terms if we keep seeing, is there a number on the top and the bottom we can divide by? And if there is, then we do that. For example, what can we divide both 50 and 100 by? You could divide them, now to go the quickest, you could divide them by 2, and if you divide them by 2, this would become 25 and this would become 50. But that might not be the lowest terms yet. Then you might say, well, I could divide them both by 5. And if I divided them both by 5,
Now have the rest of the grade 12 students that have not yet had their photos taken. If you can please
then you'd get 5 and 10.
do so. Thank you.
And that's still equal to a half. All of these ones are equivalent along the way. And then if you divided by 5 again, you'd get 1/2. And then when you get to 1 and 2, there's no more whole numbers that you can divide by. So we would say that's in lowest terms. Now, what we're going to get to with proportions, and what we're learning this for, is often throughout life there are proportions that are set up. For example, there are a certain number of inches in a foot. Does anyone know how many inches there are in a foot? 12. So if I have 40 inches, we're going to want to know how many feet is that. So we're going to want to see if we can figure that out. The way that we're going to do that is we're going to set up a proportion with equivalent fractions. What's going to happen is we're going to say, I don't know how many feet that is, but it's going to make a fraction with 40 inches. That's the same as having 1 foot is equal to 12 inches. And then we're going to see if we can figure out what that fraction will be for equivalence. Now I chose 40 because it doesn't work out nicely. But if I chose a nicer number, like 36, sure. What number would have to be here so it's the same as 1/12? That's what we're going to try and figure out. And it's equal to 3. So we're going to look at, well, how do we do those kind of things? How do we, once we know a proportion like 1/12, that there's 12 inches in 1 foot, how do we set it up so we can figure out that 36 inches is 3 feet? And 36 inches is an easy one because the mental math isn't too big. But what do we do when we have 4,512 inches? That's not one that's going to be easy math to do. How do we set that up so we can solve it and figure that out? Because if you go into any line of work that involves construction, then you're going to be dealing with a lot of measurements, and those measurements, for the most part, are in inches. And you're going to have to do things like figure out how many inches there are in 17 feet or vice versa. So we've done some equivalent fractions already. The question is, we're going to find out now, can we solve for x like we did in that question before if two fractions are equivalent? And what I'll get you to write down first here is some strategies. So there's an algebraic method that we're going to learn, and there's a pattern method. And we're going to learn them both, and we're going to know how to do both of them well. And I'm going to start here. I'm going to do the algebra way. The algebra way is going to be very important because you're going to have to use it when the numbers get messy. When the numbers get messy that you can't see an easy pattern, you're going to use the algebra way. We're going to split the page here. When the numbers are easy, then the pattern way is often faster and really easy to do. But we're going to do the algebra way and the pattern way for each of these, and we want to get good at both of them so that depending on if the numbers are nice, we can use the pattern way because it's faster. If the numbers aren't nice, we're not like, oh, I'm screwed because I can't do anything because the numbers aren't nice. We can still be able to figure it out. So here we've got x over 20 is equal to 2 over 5. And this is an equation. It's an equation because there's an equal sign. In math, we say it's an equation if we have an equal sign. And one of the things from equation solving that you might remember from grade 9 is that if you do something to one side of the equation, you have to do the same thing to the other side to keep them equal. It's almost like a balance beam. If I have a balance beam like this and they're equal, if I add 2 to this side, they're not going to be equal. I need to add 2 to the other side as well to keep it equal. So that's an idea. So what we do to one side of the equation, we need to do the other. And in an algebra method, what we're trying to do is, this is the number that we don't know. Some of you might be able to see already what that number is. That's great. But in an algebra way, what you're going to want to say is, that's the number I don't know. That's what I want to get all by itself on one side of the equation. And then if I have just numbers on the other side of the equation, I'll be able to tell what it is. So here, right now, the number that we want to find is being divided by 20. What's the opposite of dividing by 20? Multiply. So if you always do the opposite, if I don't want that 20 there, I'm going to need to multiply by 20. But if I multiply by 20 on one side of the equation, I have to multiply by 20 on the other side of the equation. What's going to happen is multiplying by 20 and dividing by 20, since those are opposites of each other, what you can show is those are going to cancel out. On the other side of the equation, you've got 2/5 times 20. You can go to your calculator and type that in. 2 divided by 5 times 20, push enter, and you're going to get 8. That's the algebra way. Often it'll involve using your calculator. How would I do this without? Well, I would change my 20 to be 20 over 1 to make it a fraction. And then I would say, what are my rules for multiplying fractions? Multiply the top, and I multiply the bottoms. So I would do 2 times 20. That would give me 40. 5 times 1. That would give me 5. And I'm left with the fraction of 40 divided by 5. And that is an improper fraction. But if I type 40 divided by 5 into my calculator, I'm going to get 8. So the algebra method will often use your calculator. Once you've multiplied both sides by 20, you'd type it into your calculator and you would get the answer. The pattern way is a nice way because you can often see things and do mental math without having to use your calculator. So for example, here the pattern way is I have equivalent fractions. What would I have to multiply the 5 by to get a 20? I'd have to multiply it by 4. Well, if I did the same thing up here, if I multiply by 4, what would x be? X would be 8. Same answer, quicker in the pattern way, but the pattern way only works nice if you have nice numbers. If I had decimals here, 20.32 and 5.419, bleh, then you would want to go to your algebra way. You could do that as well, yeah. And that, it does the same thing in the end. So there's our first one with an algebra way and a pattern way. Yes?
Is there any times where the algebra way won't work?
No. The algebra way will always work. The pattern way is a shortcut way that won't work if the numbers aren't nice. Okay? So what we're looking at here, let's do our next example. We've got x over 4 is 15 over 20. This one can be done in both ways. So I'll get you to split your page up. I want you to see if you can do it the algebra way. I want you to see if you can do it the pattern way. All right, for the algebra way, again, we have that x. That's what we want to find out. Right now, our x, which is right here, is being divided by 4. The opposite of dividing by 4, multiply by 4. And if we do that to one side, we do that to the other side. The 4's will cancel out on this side, and we'll just have x. And when we multiply this out in our calculator, we're going to get 3. The pattern way. Start with our fraction, and we're going to have to look, is there an easy number that we either multiply or divide by to find our number? Well, I'm looking at the 4 and the 20. If I went 20 back to the 4, what would I have to do? I'd have to divide by 5. So if I do the same thing here, I'd have to take my 15 and divide by 5, and 15 divide by 5, tells me that x has to be 3. Now, what we just did